Hello, today we will talk about semiconductor failure analysis. Semiconductors, which are integrated circuits, are currently essential components in a variety of industries. If a semiconductor does not function properly, a failure analysis can be performed to detect the fault. The following explains how to analyze semiconductor defects. However, due to the EMC material used to protect the internal components, such as the chip, it is difficult to check the internal state of the semiconductor. There are two main methods for examining the interior of these semiconductors. These are non-destructive analysis and destructive analysis. The first is non-destructive analysis using X-ray, CT, and SAT. Non-destructive analysis is used to check for defects such as delamination or cracks in the semiconductor. X-ray involves projecting X-rays or gamma rays onto an object and capturing the transmitted beam using film or digital detectors to create an image. This is 2D projection image. CT uses multiple angles to capture images and uses a reconstruction algorithm to generate 3D volume data. This allows the internal structure to be separated and measured without relying on a single projection. The following is APRO's X-ray equipment manufactured by Shimadzu Corporation. This equipment can perform both X-ray and CT scans. SAT generates high-frequency sound waves from a transducer and measures the time and amplitude of signals reflected and scattered within the material to estimate the location, size, and shape of defects. Pulse echo, TOFD, PAUT, etc. The following is APRO's SAT equipment manufactured by Hitachi Corporation. Secondly, there is the destructive analysis using decapsulation, EMMI, and microsectioning. This is used to confirm any defects that have not been identified by non-destructive analysis. Therefore, destructive analysis is the final method to be carried out. Firstly, decapsulation is the first step in semiconductor failure analysis, opening up the internal structure to enable subsequent EMMI, OBIRCH, FIB, and SEM analysis. Chemical or mechanical removal of molding compounds, epoxy, etc., from semiconductor packages using acids and plasma to expose the internal chip, bonding wires, and interconnections. Although it has the disadvantage of being impossible to restore to its original state, this method can be used to check for corrosion, aluminum pad lift, bonding defects, ESD and EMMI pre-check exposure, and internal packaging defects. Next, EMMI detects and visualizes the faint infrared and light emissions generated by the semiconductor device during operation, enabling the location of the defect to be identified. This method is classified as destructive analysis because decapsulation is required first. EMMI analysis itself does not cause physical damage. Finally, there is microsectioning. This involves cutting, grinding, and polishing parts. This exposes the internal structure as a physical cross-section for analysis using a microscope, SEM, etc. It is possible to make quantitative measurements of dimensions, thickness, crack length, etc. We have FIB SEM equipment that can perform such analyses. Next, we will show you some relevant examples. First, here is an example of semiconductor EMMI analysis. Next is an example of power semiconductor chip defect analysis. Finally, here is an example of power semiconductor chip structural analysis. That concludes our overview of semiconductor failure analysis. At APRO, we conduct a wide range of analyses and tests beyond this specific field. Please feel free to contact us at any time. Thank you.